Hello aviators, I welcome you on board flight of Captain Vijay in the series of flights to study air regulations for Dgca, CPL and Atpl examination. Today we will fly through the topic of parallel runway operations. In this video, we will cover different types of parallel runway operations, procedures, limitations on simultaneous approach and departures, as well as minimum separation. So fasten your seatbelts as we are ready for takeoff. You all must have seen a runway at an airport. If there is a single runway, all aeroplanes have to take off as well as land on the same runway. This imposes a maximum limit on the number of traffic which the airport can handle. So if traffic density at an airport increases, the solution to handle more traffic is to have more than one runway. You can use one runway only for departure and other only for landing. This can increase the traffic load which an airport can handle. Parallel runways can be used in mixed mode also. So in this video lesson, we will see how approaches and departures are executed where parallel runways exist. Mainly we are looking at procedures, limitations, restrictions imposed during parallel runway operations to ensure safety. And by safety, what we mean is that safe vertical and horizontal separation should always exist between two traffics in near proximity. First, we will go through the approaches conducted on parallel runway. If an airport is having parallel runway close to each other and one aircraft each is on approach to land for each of the parallel runway, this situation is called simultaneous parallel instrument approach. And there are two modes in simultaneous parallel instrument approach. In mode 1, separation between the runway is large, hence parallel approaches are independent of each other. And in mode 2, the runways are close to each other, hence it is called dependent parallel approach. Mode 1, independent parallel approaches. Note on the screen that for the independent mode, distance between two runway has to be more than 1035 meter. Approaches are made to parallel runways independently. Radar separation minima between aircraft using adjacent ILS are not applied. So, both aircraft can be abeam each other when established on ILS approach. Each pair of parallel approaches will have a high side and a low side to provide vertical separation until aircraft are established inbound on the respective ILS localizer course. The high side will be 1000 feet above the low side. Before vertical separation can be reduced below 1000 feet, both aircraft on the simultaneous parallel approach must be established on the ILS localizer centerline. The other limitations are minimum of 1 nautical mile leg on intercept course, intercept heading not more than 30 degrees away from runway heading, and 2 nautical miles straight and level leg on finals before intercepting glide slope. Mode 2, dependent parallel approaches. Note on the screen that for dependent mode also the distance between two runway has to be more than 915 meter. Radar separation minima between aircraft using adjacent ILS are applied. What it means is that even though they are making approaches for different runways, they cannot be closer than 2 nautical miles to each other. This is what implies by saying that it is a dependent parallel approach. It also means that they will never be abeam each other on approach. Regardless of weather conditions, all approaches are to be radar monitored with radar controllers specially detailed for that duty. During vectoring to intercept the localizer, the maximum intercept angle is permitted is 30 degree. Minimum of 1 nautical mile straight and level flight is required before localizer intercept. And vectoring is also to ensure that the localizer track is intercepted and flown for at least 2 nautical mile before glide path intercept. Minimum radar separation between two traffic on approach for the same runway is 3 nautical mile, and missed approach track is to diverge by at least 30 degree from each other. Simultaneous parallel instrument departures. Similar to parallel approaches, we can have simultaneous parallel departures, and they fall in the category of mode 3 operation. So mode 3, simultaneous instrument departures. Note on the screen that for mode 3 departure, the distance between two runways has to be more than 760 meter. This operation is known as mode 3 independent parallel departure. It involves simultaneous departure for aircraft departing in the same direction from parallel runways. All departing traffic must be identified by radar at a distance of not more than 1 nautical mile from dead end of runway. All departure tracks must diverge by a minimum of 15 degrees immediately after takeoff. Moving on to mode 4, which is called segregated departures and arrivals. This operation is known as mode 4 segregated parallel operations. In this mode, one runway is exclusively used for approach and the other runway is used exclusively for departure. Note on the screen that absolute minimum distance required between parallel runways is 300 meter when runway are offset from each other, and if the runway thresholds are abeam each other, then the minimum distance is 760 meters. Semi-mixed operations. In essence, the option for use of parallel runway is totally flexible, and a situation may exist when one runway is used only for departure and the other runway is used for both departure and arrival, or vice versa. So this will be called semi-mixed operations. For all parallel runway operations, radar surveillance and in some cases the radar control must be provided. Without radar, the parallel runway operations are suspended and single runway operation is resorted to. Imagine a scenario when mode 1 independent parallel approaches are in progress for two parallel runways. Since it is an independent operation, there may be a situation when two aeroplanes on approach are exactly abeam each other. Now just imagine that if there is a failure of localizer or localizer beam is not giving the correct indication, one of them may drift towards the other, and this situation can lead to a very serious safety hazard, or in extreme case it can lead to mid-air collision close to the ground. And to prevent such a scenario, no transgression zone has been marked so that none of the aircraft on approach is allowed to enter this zone. In the context of mode 1 independent parallel approaches, this is a corridor of airspace of defined dimension located centrally between the two extended runway center lines. Penetration of no transgression zone by an aircraft requires controller intervention immediately to maneuver a threatened aircraft on the adjacent approach. Normally, this will require a turn away from the other aircraft and an immediate climb to minimum safety altitude. It's a legal requirement that no transgression zone must be at least 610 meter wide. Minimum spacing of parallel runways. The worst case is where the runway thresholds are adjacent to each other. This means that two approaching aircraft, for instance, will always be at the same altitude when at the same distance from touchdown. If the runway thresholds are staggered, then the distance between the runway can be reduced. So runway can be closer by a distance of 30 meter if there is a overlap of 150 meter between the threshold of the runway. So minimum spacing for mode 1 operation is 1035 meter, for mode 2 is 915 meter, and for mode 3 and 4 is 760 meter. So with this we have completed the video lesson on parallel runway operations and we have arrived at our destination. Subscribe the channel for more such informative videos on aviation. Do not forget to comment below about how did you like the video or you want me to cover a specific topic. Like, share, subscribe if you wish. Hope to see you on board again for the next flight. Until then, happy landings.